Hi, John here. Thanks for watching. We're looking at a detailed walkthrough now of the first draft of a single-digit test program for my timer sign. Remember, my sign is going to be used as a countdown timer, kind of a, well, not really a stopwatch, but just a timer. It'll count down to 0, and then it'll change red to indicate that the time has elapsed. So what are we doing here? I took the Arduino, the Adafruit rather, strip test application source code that we already went through before to use to test the sign and the strips, and deleted every single thing except for this. By the time I was done, the only thing left pretty much was this thing right here. This, by the way, is the code that you need to put in to tell the Adafruit library what kind of LEDs you're using. I'm using WS812 LEDs, and this is the code for that when you create the NeoPixel library object. So let's look at how we do all this. We're still using pin number 6 to connect to our data input signal. I've got a total of 14 LEDs in this particular design because I'm using the small digit. We're only going to light up one number on my sign, the small one that's got 7 segments of 2 LEDs each, so that's 14 total. We need to create the Adafruit NeoPixel object representing our strip. I'm going to call it this, LED strip. It needs to know the number of LEDs, what pin it's going to be connected to, and what kind of LEDs are in use using this symbol here. All right, so what do we do? Normal Arduino stuff. We start up the app by invoking the setup function. And what I'm going to do is I'm going to call begin on my LED strip, the one-time call you need to make to the Adafruit library to let it know that you're ready to use it. I'm then going to call show right away, even though I haven't done anything to it. The idea being that no colors have been set yet, therefore this will flush a blank screen out to all my LEDs. It basically turns off all the LEDs if any of them happen to currently be on. This is a comment in case I wanted to play around with some debugging to the serial monitor. I'll just comment that back in if need be. I then reset my counter. Let's have a look-see at what that function does. It sets the counter value to 0. The counter variable is documented right here, and it represents the number of ticks that have transpired since the Arduino is booted up. It's kind of like it's the time I want to display on my screen. I also set this variable next to the result of millis, the timer that the Arduino library gives you, which represents the number of milliseconds since the Arduino itself has booted. I initialize that to the current time. We'll see how that's used when we get to the main loop function. When we're done with that, the setup function is done and it simply returns. The Arduino software after that simply repeatedly calls the main loop function right here. I skipped over a few things we'll come back to as we move forward. The my loop function simply goes around and around like this. It does not have any delay in here or anything. I'm just using this millis function to figure out the time. So how do we do this? The period between updating my sign is going to be 1,000 milliseconds. So in this test app, once a second, I want to update my screen. So basically, this thing will count in seconds. I ask what time it is right now. Okay. I then ask if now is greater than or equal to the next time. Now remember, I initialize the next time to the current time up here in counter reset. Well, that just simply means that this will be true the first time through the loop. After that, we'll see what happens if we advance the next period and so on. We'll get there in a second. So what does this thing do when that's true? As I said, it is the first time in, so it calls the digit function, which we'll look at, and it gives it the value of counter mod 17. So this is just going to be 0 through 16 as we add 1 to counter every time we go through this loop here. So the digit on the display will go from 0 to 16, 0 to 16. Now the reason that is true and it didn't go from 0 to 9, as you might think, is because I have a hexadecimal value and I also have a dash. We'll see in a minute when we look at the font. So what does this thing do? It says I want to put this digit on the digit, the one and only one that we're testing right now, and it passes this variable called FG, which I created for the foreground color. So let's look up here at this stuff that I skipped over. This macro here I use so I can change the brightness of my sign. That's all that really represents. The highest brightness you can put in this NeoPixel color function is 255, maximum brightness. So the foreground is the color of this red, green, and blue combination. So this is a slightly bluish green, or rather greenish blue, is what this thing represents here. The BG color is all zeros, which is off or black. All right, so this is a greenish blue, and this is a black color for the background. So this thing is going to pass it this greenish blue color. This digit function will update and set the LEDs to the correct values. We'll see that in a minute. And when that's done, I call LED strip show, because the LEDs are not actually updated until you flush the settings that I'm going to do in the digit function up here using this function here. When I'm done flushing it out onto this display, I add period to this next value. All right, so let's take another look back at how that thing works. Remember the first time in here, next equals the time that the Arduino boots, and it doesn't do a whole lot, so not a lot of time passes, possibly 0 milliseconds have passed. So now, once I execute the loop the very first time, is probably actually going to equal next, or might be 1 greater than next. Therefore, this thing will execute the body of this if. When you're in the if statement, next equals next plus this 1000 up here. So the next time loop comes through here, the value in next will equal 1000 more than it did last time. Well, presumably, it takes less than a whole second to do all this work, so this will be false for a while loop is being called. So in the Arduino world, loop is just called. There's a little function somewhere else in their library that says while one loop. So a whole bazillion times this will get called, but the millis value will not return a value great enough until 1 second has passed, roughly, because this takes a while, as we'll see, to do its job. So this will simply step 1 second into the future each time this is called. And this is the right way to do the timing. You do not want to say next equals milli plus t period, because that would be t period 1 second away from the time this line executes, which is not what you want. You want 1 second since the last time this expression was true. All right? Once we've advanced our time period, once we the next time value, we add 1 to the counter because we just updated the display. So 1 second into the future, roughly, this will then execute again with value 1 greater than before and update the screen. So that's how the main loop function works, and that's essentially the whole thing once we talk about how this thing goes, all right, which is where all the real magic happens. So this thing simply calls this once a second with an increasing value. That's what it does. Because I've created a display, I need to define what the font looks like. So here is a little ASCII chart of what my font here is going to be used for. If we consider the 7 segments, and remember this is in the order in which I wired them in the previous episodes of this series. The wiring for a single strip LED goes in this side, up and around like I just drew, and out on this side over here. If it's a double strip LED, they go up, down, around, turns around, comes back the other way, and back out. And that's a little more complicated to write the code for. So this time we're going to do a single strip LED for simplicity. Now, every time I say I want to put a value on that LED, I need to tell it which ones of these segments need to be on and which ones need to be off. For example, if I want to put the number 1 on here, I want number 0, as I've labeled it here, and number 4 to go on. So I built this chart, this table, for every value I could print. As you can see, it goes 0 through 9, A through F for hex, plus a dash down here. So that number, like whatever it is, 17 down here would be the, actually this would be 16, would be the dash symbol. So 0 looks like this, 1 looks like that, and so on. Now I just drew the 1 up here, and I said 0 and 4 should be on with all the rest off, so we should see 2 bits in here be set to 1, and we do. So that sanity checks out. But which ones need to be on? Well, number 0 and number 4. You start on the right, that's 0, 1, 2, 3, and 4. That's how the 1 is drawn. The 0 is all but number 3. So we got 0, 1, 2, 3 here is a 0, 4, 5, and 6. Now this top one up here, number 7, we don't need. It's the 8th column in our byte is just not used. So I'm going to just set all those to 0. All right, so that's how the font works. For each one of these numbers and letters and so on, I decided which segment should be on and off and put it in this font table. The index in the font is merely the value that I want to put on the display. So font sub 0 is the bit mask for 0. Font sub 1 is the bit mask for 1, and so on. All right, so now you know how that works. Here's how it's used. The digit function, as you recall, here's the digit, the number I want to put on the LED, and this is the color. As you remember, I passed it in the blue-green color value. So how does this function work? We need to know how many LEDs per segment, which is 2 in this example. We need to know which bits we need to have on based on the digit that was passed in, and we get that out of the font table that we just discussed. So if I put a 0 on this display the first time through, this is font sub 0, which you know has 6 ones and a 0 for the center segment. We now iterate over all the segment numbers from 0 to 6, right? 0, while less than 7, will give me 0, 1, 2, 3, 4, 5, 6, and I add 1 each time. So I'm going to call seg, which we see down here, and I'm going to pass it the number, the address of the first LED that I want to set to this color that I've passed in. Ooh, crazy mouse. Seg will set every LED starting at this address for this many LEDs to a color given over here. Actually, I guess it would be easier to read this. Segment is this starting LED, give it the quantity of LEDs, and then a color, which I'm going to just pass through from here if it is going to be turned on. Otherwise, I'm going to give it a background color. So the way this works is I take the K value, which goes from 0 to 6. I multiply that by LPS, which we know is 2. So the first time K is 0, this value is 0. LED address number 0. This is the 2 LEDs I want turned on. And I ask, is the least significant bit of V, the bit mask from font, on right now? And as we know for 0, it is. Bit number 0 is the first time through. I'm going to set the blue-green color. If we had a 0 over there, like you do for, I don't know, the letter E, would have that segment turned off, we would have passed the background color. All right? So when we're done with that, we then shift V right 1 slot. All right? So when we're setting a 0 down there, the first time through that loop, V has this value. The second time through the loop, it's been shifted to the right, so it now has that value. The third time through the loop, it will have this value through here. The fourth time through the loop, it'll have the value here, and so on. So essentially, every time through that loop, I'm looking at the next column to the left, right? Because I'm shifting it over each time, and I'm always asking, now that it's been shifted, is the least significant bit on now? If it is, I'm going to pass it the color that was given. If it's not, I'm going to give it the background, which is black. All right, so now we know how that works. The segment thingy down here, let's look at the body of that. Remember, we got the starting LED number in here and the quantity. So what do we want to do? I want to figure out a range, right? So I want to go from starting LED, and I want to say, well, what's the last one, so I can make a nice loop here. The last would be starting LED plus quantity right here, which is actually the address of the LED after the last one that I want to set. Okay, so I could have subtracted 1 to get the number that is the last one, but it doesn't really matter. It's relative to where I want to be. I can simply say, while this starting LED is less than this last calculated one, all right? I never want to get to this value. I will then come in here and say, well, set the starting LED that I was given to the color that I was given. Not a problem. We're finally actually setting the colors here. Then we add 1 to the starting LED and we go around and around and around. So what happens here? The first time this is 0, we set LED 0 to green, add 1. Next time the thing is a 1. 1 is less than 2. We set the color. We add 1. Now 2 is less than 2. Not, right? So that's false. We come out down here and this thing finishes and we come back up to the loop we already discussed here. And when that thing is all done with all 7 segments, we come up to here and it does the show and advances and goes on around. That is the whole ball game right there. Let's fire it up on the sign and see how it works. So thanks for watching the video. If you like it, give me a thumbs up or give me a comment. If you think I could have done better or you could have done better, feel free to throw a comment or send me a message. Or call me on the phone. We'll see you next time with a more with all the digits running.